In this video, we're going to go over number 1 in the Exploring Exponential Function notes. And by doing number 1, it will help you to do number 2, and also will help you with the worksheet titled Using Exponential Functions to Model, and also solve percent increase and percent decrease problems. For number 1 here, it says Patty went to the pet store and bought 4 rabbits. Amazingly, her rabbit population tripled every year. So let's look at this table and see if we can find some patterns. Looks like this row here is completely filled in. Let's go start at this row and go down, and then we can work our way back up to see if we can see a pattern. So here it's 4 times 4 times 3 times 3. And then here it's 4 times 3 times 3 times 3. So it looks like they added a multiple of 3. They added 1, 3, and the n. They multiplied by 3 one time. Right? And if you take a look at these exponents, so this was exponent of 2, now this exponent of 3. So this exponent 2 maybe corresponds to these two 3's. This exponent of 3 corresponds to multiplying 3 by itself 3 times. So for the exponential form, if we did it right above it, we could put 4 times 3, and notice we have just 1 3, so we could just put a 1. And then we have 4 times 3, and here we have no 3, so we put 0. So remember, anything to the exponent 0 is going to be 1. So this is going to be like 4 times 3 to the 0. We do 3 to the 0, that's going to give you 1. So it'll be 4 times 1, which is 4. If we multiplied 4 times 3 times 3 times 3, that's going to give us 108. So the next row is 4 times 3 times 3 times 3 times 3, and that will give us 324. Notice again we have 4 3's, so it's going to be 4 times 3 to the 4th. there are 4 3's. I'm going to add one more 3, so 4 times 3 times 3 times 3 times 3 times 3. So now there are 5 3's, so 4 times 3 to the 5th. And that was going to give us 972. So it's going to be, in general, 4 times 3 to the t. Right, notice the t. So 1 and 1 and 1. Right. 2, 2, 2. So whatever t is going to be our exponent. And we'll leave those other 2 red circles because it's hard to erase it without erasing the black exponents. Alright, for letter B, write a recursive formula that models this situation. So u sub 0 is equal to 4. Right, it tells us right here u sub 0 is equal to 4. So that's, what does that mean? That means at year 0 there are 4 rabbits. So that's how many rabbits we start off with. And in general, u sub n is equal to u sub n minus 1 times 3. So what that means is, well, let me erase this first. Just so it's not as cluttered. What that means is u sub n is any term. So any term is equal to the term before it. That's why it's n minus 1 times 3. Right, how do we get 108? We got 108 by taking the term before it, 36, and multiplying it by 3. How do we get the term 324? We took the term before it, 108, and multiplied by 3. How do we get 972? We took the term before it, 324, and multiplied by 3. So that's what this part is saying. The any term equals the term before it times 3. Where n is greater than or equal to 1. We put n as greater than or equal to 1 because let's say that n was 0. If n was 0, then if you put, let me erase this now. If you put, for this n, if you put 0, then you'd have 0 minus 1, which is negative 1. But the time in the year starts at 0, it doesn't start at negative 1. So that's why we put n is greater than or equal to 1. If we put I need a new marker. This marker is a little bit too round. It's hard to make fine point marks here, but let me try to rewrite it. U sub n minus 1. So if we put 1 for n, that's 1 minus 1, which is 0. Which is where we start. We start at 0. The explicit formula for the formula that models this situation. The explicit formula is going to come from what we got in that cell for the exponential form. I erased it, but it's what we put before. So it was R of t equals 4 times 3 to the exponent t. So we used R for rabbits and T for time. Okay. R for rabbits and T for time. So those variables could change depending on the problem. Is the number of rabbits increasing or decreasing? Well, it goes from 4 to 12 to 36 to 108 to 324, so it's going to be increasing. Use your model to find the number of rabbits after 8 years. So we're going to just substitute 8 for t. 4 times 3 to the 8th. When you put this into your calculator, make sure you do 3 to the 8th first, and then multiply that by 4. If you don't have a calculator, you can Google graphing calculator. And then you can choose from either Desmos or Algebra. From either one of those, either the Desmos or Algebra will give you, will allow you to graph, but it also allow you to do computations like this one. So this is 4 times And then 3 to the 8th is 6,561, which will give us 26,244. For letter F, use your model to find the number of rabbits after 12 years. So this time we have R 12. So it's going to be 4 times 3 to the 12th. Which will give us R to the 12th equals 4 times 3 to the 12th is 531,441. And that will equal 2,125,764. For letter G, use your model and a calculator to estimate, by guess and check, the number of years it will take to reach 10 million rabbits. So if we do R of 13, we would get 6,377,292 rabbits. If we do R of 14, that'll give us 19,131,876 rabbits. So we know that the number of rabbits will be between 13, or the number of years will be between 13 and 14. 10 million is a little bit closer to 6 million than it is to 19 million. So an estimate would be around 13.4. Sorry. Yeah, 13.4.